Hi everyone, welcome to this video about Mendeleev's periodic table. This is an exam question about Mendeleev's table and a little bit about the structure of atoms as well. So it says figure 1 shows part of Mendeleev's version of the periodic table. Which group of elements had not been discovered when Mendeleev's version of the periodic table was published? Now if you have a look, you will see most of the elements on there apart from group 0. So group 0, otherwise known as the noble gases, are not on that table, and the reason being they hadn't been discovered at that time. And the reason why they probably took so long to be discovered is that they're very, very unreactive, so it was difficult to know that they were actually present as elements. So the next part is looking at models of the atom. So there's 4 models of the atom shown. It says which one represents the plum pudding model. So hopefully you all know that that is B. Okay, you've got that positive sort of centre, dough if you like, the pudding, and then the negative plums dotted throughout. Okay. It then said which model resulted from Chadwick's experimental work. Now just be aware that James Chadwick discovered the neutron. Okay, so any models, that was the last subatomic particle to be discovered. So any models above that contain neutron would be the Chadwick model. It's going to have to be A, because if you look in the nucleus, you've got protons positive, and then you've got those neutrons and neutral. So A is the answer to the Chadwick experimental work. Now, potassium has different isotopes. What is meant by isotopes? You should refer to subatomic particles. So remember, that is protons, neutrons and electrons. You need to talk about them. So first of all, isotope is the same number of protons but a different number of neutrons, and as a result of that it will have a different mass. So just to give you an example, carbon, which is carbon 12 and carbon 13 are isotopes. Reason for that is they both have the same number of protons, 6 and 6, but then their protons are both 6, however their neutrons are different. This one's got 6 neutrons, whereas this one here has got 7, so they are isotopes. The next one is calculating what we call the relative atomic mass after being given the isotope. So what will happen in these questions is you'll be given a mass number of each isotope and a percentage, and what you need to do is you need to multiply the mass number, and I'm going to highlight these in orange. You multiply the oranges basically by the percentages which I've put in yellow. So it should be a relatively easy calculation once you do that. So I'm going to do 39 multiplied by 93.1. I'll put that in brackets. And I'm going to add to that 41 multiplied by the percentage for 41, which is 6.9. And then I divide the whole calculation by 100. Now if I work all of that out, I should get 39.138. And the question says quite clearly at the top, give your answer to 1 decimal place. So I have to round that to 1 dp. So that's going to leave me with a relative mass of 39.1. And I'll just pop that in the bottom, 39.1. So just be aware with this one, the key thing is if you use the values and you get the answer a little bit wrong, provided you have had what I'd call a reasonable attempt at using the numbers in the question, and then you've got the wrong answer but you've rounded it to 1 decimal place, you'll still get 1 out of 3. So any questions like this where you've got to give your answer to 1 dp, 3 significant figures, whatever, have an attempt at the calculation, and even if you are, as long as you're using the numbers from the question, you may be using them incorrectly, If you then give your answer to 3 significant figures or 1 decimal place, you'll still get some credit for doing that. So it is worth doing that in them questions, particularly if you don't fully understand what to do. So that's it for this one, guys. We'll see you in the next one.